Hi, my name's Sandy Atkins. I'm a compliance officer at Energy Safe Victoria, and I work in the Renewable Energy Safety team, and I'll be delivering this toolbox talk. This toolbox talk is about parallel earth neutral connections with battery system installations. It will highlight the additional testing requirements in AS/NZS 4777.1 when installing a battery system that provides an alternative or backup supply when the grid goes down. Incorrect neutral earth connections can result in an increased risk of electric shock or failure of RCDs to detect an earth leakage. We will cover off the correct earth referencing and ensuring the neutral is continuous in this toolbox talk. How does this occur? Here is an example that has been identified through an Energy Safe Victoria shock investigation. Some manufacturers have installation instructions saying to install a second earth neutral connection on the alternative supply output, which is highlighted here in the orange circle. In grid mode, the supplementary supply earth and neutral connection are in parallel and therefore not compliant with AS/NZS 3000, as the earth conductor shall not carry current under normal operation. So why do manufacturers do this? The product standard for inverters requires both active and neutral to open on the grid port when the grid goes down. This would make the alternative supply not earth referenced anymore, so they have in their instructions to add an additional earth neutral link at the alternative supply output port, as you can see here in the orange circle. Sometimes this is not part of the installation requirements, but it can happen in the product itself. Fortunately, AS/NZS 4777.1 has an easy test to identify this, and effectively you turn the grid on, you turn the inverter on, and you turn the alternative supply port on. Then anything connected to the grid supply, you turn that off, and then ensure that there is a load connected to the alternative supply. So in this example, it's step 5, a kettle is on. You test the current that flows in the active conductor, for example 2 amps. Then you test the current flowing in the neutral conductor of the alternative supply, and again you would expect to see the same current. Then you test the earth conductor to see if there's any current flowing through it. As you can see in this example, the active conductor has roughly 1.7 amps flowing through it, whereas the neutral conductor has 1 amp flowing through it, and there's almost 0.7 of an amp flowing through the earth. In this case, this indicates a failed condition, so it's a relatively easy test to identify that you have a problem. Due to the different ways manufacturers or systems can do this earth referencing of the neutral on the alternative supply, it's important to do the exact same test with the grid in the off position. The next important test in AS/NZS 4777.1 is ensuring the neutral conductor is continuous in alternative or backup supply mode. These two images are from products being sold in Australia. In the left picture, it doesn't show that there is a connection between the grid and the backup neutral, yet in the words at the top here, it states that that is a requirement. The picture on the right has words at the top that mentions that this is an example of the connection for Australia. And if you notice, there's an additional neutral link connection here. But again, this is an appendix. Now what happens if you don't join the neutrals? If the neutral is not continuous from the neutral bar where the MEN link is, then in alternative supply, the supply will not be referenced to earth. Therefore, we need to test that the neutral is continuous. The simplest way to test for this is to put the system into alternative supply mode and test the supply voltages with respect to earth. As you can see in this image, that it is a non-compliant installation. There's nearly 83 volts measured on the neutral with respect to earth, and this was identified through Solar Victoria's audit program. A compliant installation would have 0 volts between earth and neutral and 230 volts between earth and the alternative supply active. Now that brings me to the end of this toolbox talk. I hope you all got something out of it. and need to ensure that when you're installing a battery system with an alternative or backup supply, that you know the appropriate tests to ensure that it's going to be compliant and safe. Thank you.